Hi everybody, welcome back. This is our second video for 1.3 geometric sequence. We're starting off at example 4. We left off example 3 the other day, and this is on page 15 of your booklet. Right now we're going to do 4a and b, and I will go through the step by step. So what I want to do first is, I really think this is important, is what we do is we write in our information on the side of the page. You don't have to. Again, this is just recommended, and you go from there. It's up to yourself. So we're looking for, we know T1 is equal to 2, and we know that R value, well, we check, of course, but the R value is, you can clearly see that it's -3, because -6 divided by 2 is -3, or 18 divided by -6. Either way, your common ratio is 3. To get from one value to the next, it's multiplying by -3. That's a common ratio. And then we have n. We know n is equal to 7. We have 7 terms because we're looking for the 7th term. That's all we know. So it's asking to find the general term and the 7th term, right? So to find the general term is basically the formula. We're going to fill it in. So we go up, get our formula. You would obtain this from your formula sheet. You write in your formula. Very simple. And then you start filling in the information. So t to the n is equal to first term, which is 2, ratio, which is 3. So we're going to use our brackets here. 3, sorry, -3. My apologies. And it's going to be to the n minus 1. So we're going to want to get our exponent there. Apologies, insert my exponent, and to the n minus 1. Okay, so there's a formula. That's all we need. That's the first part, the general term. So let's find the general term. The general term is the formula used based on the information that you have. Next thing we're going to do is we're going to find the 7th term. So remember, your formula for when you're looking for general term is going to have Tn in it. Obviously, that's what you're looking for, and you'll leave n alone. You just leave it blank. Now, for the 7th term, this is when you fill the 7 in for n. So you're actually calculating a value. So the first one, if they ask for the general term, it's just a formula. And if they ask specifically what term you're looking for, in this case 7, then we can fill in 7 for n. Okay? So we take that, we fill it in, and we get that'd be 7 minus 1, which is 6. We go to the calculator, we look for 3 to the power of 6. So we know 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. Again, if you are looking at it and you see that we have a negative here, the base is -3, that's fine. It just means you're going to multiply it, or you're going to multiply -3 by itself 6 times, which essentially is going to bring it back to an even number, right? Because a negative times a negative is a positive times a negative. So if you may recall from grade 10 or other conversations we had, but if you go to the exponents positive, you'll end up with even for negatives, and if it's a negative exponent, or sorry, an odd exponent, you'll end up with a negative number. Either way, you can just plug this in your calculator. I'm just doing mental math, but it's completely up to yourself. So -3 raised to the power of 6 is 729, and it's positive because it's an even exponent. And then we just multiply those together, double that, multiply it by 2, and we get 1458. There we go. So what does this mean? The general term, that's it. When you're asking for the general term, you're looking for Tn, and then when you're actually looking for a specific term, so the 7th term, we fill it in for the general term, we get T to the 7 is equal to 4. So what does that mean? If we continue this sequence, we continue to multiply each number by 3, you'll end up with 1458. And I can show you that if you want, up here, for those of you that are skeptical about that. So if I took 18 and I multiplied it by 3, take 18, multiply it by, -3, I would get -54. If I multiply -54 by 3, I get positive 162. I'm in the 5th term, now I'm going to the 6. I multiply by -3, and I get -486. And then I multiply that again by -3, and then d is 50. Again, it's a quick check we can do here, because it's only 7 terms, but again, if that was the 700th term, you wouldn't want to be doing that, right? So I'll just take that away. I just wanted to show you that as a little, proving that it is correct. Okay. Now we'll move on to B. B's done the same way, only we're dealing with fractions now. Our sequence has fractions, which is not a big deal. All right, so what we'll do is we'll write out what we know. So we know T1 is equal to 1/3. Okay, we're going to get the first term, T1 T1 is equal to 1/3 again. This is optional, whether you want to write the information or not. Just something I recommend. Again, completely up to yourself. Let's determine the R value now. The common ratio. The common ratio comes from the consecutive terms, dividing them again. So how am I getting from 1/3 to 1/6? I just take my negative 1/6, then I divide it by 1/3, which would be negative 1/2. Or I'm multiplying 1 by 1, I get 1, and multiply 3 by 6, and I get, or sorry, 3 by 2 to get 6, and of course each term is being negative, so it's negative 1/3, or negative 1/2, sorry, negative 1/2. So our value is negative 1/2. Next, we have the n value, and again, it's going to be 7, because we're looking for the 7th term. It's a continuation of example 4b. All right, same formula, same steps. So we have T to the n is equal to sorry, just some formatting stuff here. My apologies. All right, let's rewrite the formula. Look for the general term here, so we leave it as Tn. First term we know is 1/3. Substitute that in 1/3. And now it's going to be multiplied. So this is where I like to bring the brackets in. So we're going to insert bracket. And then of course that's going to be a fraction. Negative 1/2. And that's all raised to the exponent of n minus 1. So that's done. That is the formula for the general term. Now we're going to do the 7th term, so we just rewrite the formula from the general term, and we fill in 7 where we see n. 7, and of course we're going to put 7 here as well. Okay. And 1 subtract from 7 will give you 6, and it's going to be a negative 1/2 to the power 6. So negative 1 in the exponent is going to become negative 1 to the power 6, because we do we have to raise to the power of 6 in the numerator and denominator. So it becomes, maybe I'll show you that just to make sure it's been a little bit since maybe we did lots of exponents. So what happens is the negative 1 is raised to the power, oh, sorry, just formatting issue there. I'll go right from scratch. It's sometimes easier, I guess. Let's check it out. Alright, so we have negative 1, and of course that has to be in brackets because it's getting raised to the power 6. If it's negative, we always put that in brackets. If it's 2 to the power 6. Remember, when we raise a fraction to the power, the numerator and denominator both get to the power 6. It's important we do that. And that would give us 1 in the numerator, and that would give us 64 in the denominator. And final step is just multiplying numerators and denominators. And we end up with 1 times 1 is 1, 3 times 64 is 192. Oh, 192. So our answer is going to be, our seventh term in the sequence is going to be 192, or 1. Yeah, so that's it. And again, you can check that if you want. I don't see it necessary, but it will work. So that's it. That's example 4. Now example 5. We're going to do in the next video. So we'll wait a minute to do example 5 in the next video. So we'll see you soon. If you have any questions or feedback, please let me know. We'll see you again soon. Thanks.